In general, motor predictive maintenance solutions in the market usually just use a vibration accelerometer with ISO 10816 specification. Our solution integrates current, torque, temperature, and vibration sensors with Azure IoT service to handle diagnostics and maintenance more precisely and with greater cost effectiveness. EtherWAN and AMASTek predictive maintenance solution, wānana, combines innovative data analytics, IoT technologies, and operations consulting in a single solution. This solution contains advanced and cloud-based predictive maintenance software powered by AMASTek, combined with EtherWAN's IoT Edge Computing Cellular Gateway, AirPace, as well as advanced DAQ edge devices and temperature sensors. To enable preventive maintenance for machines, a series of processes and analyses must be carried out that convert collected sensor data to useful information that predicts the health condition of machines and crucial elements. When an abnormality occurs in the load, such as a rotary shaft or reducer, the motor does not rotate smoothly and a distortion occurs in its current waveform. The wānana current diagnosis makes it possible to capture the condition changes by comparing the normal current waveform, the ideal sine wave, and the abnormal current waveform. Most predictive maintenance solutions use vibration sensors to detect the main abnormality. This approach is even better if a temperature sensor is added. The vibration detection is based on ISO 10816. By constantly monitoring for vibrations, it can detect signs of abnormalities in various machines. However, it can do detection, but not prediction. Motor current signature analysis is an innovative method that allows a thorough analysis of the condition of the electric motor. The advantage of this method is that testing is carried out during the normal operation of the motor, and there is no need to stop and interrupt the production process. These are the situational categories as defined by ISO 10816. They allow for clear identification of motor conditions and potential problems. Additionally, AirPace can also perform AI model inference on data. This allows the system to learn and classify new data sets based on existing defined categories. This data processing is executed locally on AirPace. wānana uses Azure IoT Cloud Service for machine learning, IoT Hub, and string analysis. The IoT Edge is leveraged through AirPace to perform edge computing. The combination of these two assets, one hardware-based and one cloud-based, delivers all new capabilities for this type of application. This demo kit consists of a servo motor attached to a driven component by a belt drive, with vibration, temperature, and current sensors. This screen shows the normal status of the motor. A large screw is added to the belt wheel, causing an imbalance. This is immediately recognized by the wānana system. The vibration sensor is optional. All monitoring can be done just through analysis of the device current. wānana is a multi-purpose solution. It reduces maintenance costs, avoids equipment breakdowns, keeps motors running at peak efficiency, and extends the lifetime value of existing assets. wānana is a cost-effective solution for motor preventative maintenance. Using fewer sensors, but with greater sensitivity and advanced algorithms, wānana delivers repeatable maintenance solutions and an optimized asset lifecycle maintenance plan. And remember, if you like our videos, click subscribe to one of our pages in the links below.